Okay, finally, okay. Our last present is Consumer from Price. Chungnan National University, okay. He will present an integrated video watching history learning system.
We will talk a lot more. It's important of materials.
Hello, I'm Moon Hyun-soo at Data Network Lab in Chungnan National University. Today, as the last speaker of this Ph.D Forum, I would like to present an integrated video watching history logging system. I will ask you one question before start presentation. Do you know this? OTT services such as Netflix, YouTube, and Twitch, and IPTV services such as OLED TV, PTV, U+ TV, which is served by ISP. My presentation was aimed at this. I will answer my question. I use 4 of these, almost all. Since I'm annoyed to see ads, I even use paid service for free, such as YouTube Red, Twitch Turbo. What I showed is a video service using IP network. In the past, video services were provided by a cable or air. However, over time these days, they are being served through IP networks. These services are classified into 2 types: OTT, such as Netflix or YouTube, which watch we want video, and IPTV, which watch live programs. Nowadays, OTT can watch real-time programs, but here I will only talk about VOD. IPTV is real-time program service using IP multitask. This is the TV that we watching as we keeping change channel 1, 2, 3, 4, and more. So let me ask you one more question. What is the video you watched last week and last month, even last year? Do you remember? If we do not remember, how can find it? Or where can find it? If you are using OTT service, you can check the history. You can see it through history in your account information. However, this is provided only HTML documents. We can only check and not use it. It's not available as JSON or CSV via open APIs, so we can use our data directly. It is also difficult to check the data of years ago. We have to keep scrolling down to 1 year old. Even IPTV, which serves the real-time programs, has no history, nothing. So we have to rely on our memory to see the content seen through IPTV last week, last month, last year. But there is something strange here. Whose data is? Whose data is the video content we watched? The answer is we can easily think of our service providers and users. Service provider can store and use this data on their server. But what should the user do? Where can user find and use their data? We wanted to return the user's data to the user. If the data available, it is easy for the user know who him or she is and he or she can make a recommendation system directly. We propose this to solve this problem. It's an integrated video watching history logging system. This saves the video watching history on user side, not on the service provider server. It supports both OTT service and such as YouTube or Netflix, and IPTV, which I previously talked. The system is largely composed of 3 parts: home router, browser extension, and analysis server. The home router and browser extensions are responsible for logging IPTV and OTT watching history, respectively. The analysis server integrates this. First, let's look at the IPTV monitoring system. The system operates in 3 different orders. The first, capture IGMP packet at home router. The second is map multicast IP address to channel number. The third is retrieve content typed by a service provider server. This figure shows these 3 orders. Let's take a look closer. When user changes the channel, the setup box generates in IGMP packet. IGMP packets are forwarded to the parent router and join multicast group. When subscribing to multicast group, the real-time program data is multicasted in UDP format. We had to be able to see this IGMP request packet. This problem is solved through the home router. We installed OpenWRT, an open source router firmware on the home router. Because OpenWRT is Linux based and user can access it internally, we can see which packets are being forwarded. It is a simple task to capture IGMP packet using TCP dump and send them to the analysis server. But there is one more question here. The IGMP packet contains a multicast IP address, did not have content name or even a channel number. What we have to look for is the name of content. So we examine the multicast IP address table. We manually changed the channel and checked the multicast IP address of all channels from 1 to 600 channels. We could get the channels by mapping this table to the destination address of IGMP packet we just captured before. When capturing a packet, the timestamp is stored and the channel number is obtained. The last problem is the content name. The packet is scrambled for video data encryption. We decide to use the TV schedule table on the service provider's webpage. We are able to crawl this schedule to find out the content name by comparing channel number and timetable. As a result, we were able to store timestamp, channel number, and content name in IPTV, where we could not see the watch history. This is my raw data I watched IPTV directory. Do you remember what you saw last September? I remember. The next goal is OTT service. Since Netflix and YouTube have huge impact, it is important to store data that use them. Video logger extensions are in order of detect users behavior, users browser event, and parsing response. This figure shows the operation of the extension that stores the OTT service watching history. But here comes the question. Why use the extension? Is it not it possible to capture packet on home router like IPTV? This is because it is encrypted communication. Beyond simply scrambling video content for copyright protection and security, OTT services use strong encrypted communication. They have applied HTTP public keying technology to prevent MITM attack. So we could not see any information through capturing packet. But with the browser, the story is different. We ask the browser to show the decrypted data. We call the browser decrypted it. How can we ask the browser to display decrypted data? We were able to see that through browser extension. The browser events occur when user click video link in YouTube or Netflix or Twitch. So this browser event to generate and send a request. We register a event listener in browser extension. This event listener allow you to see which request to send when a video link is clicked. The request URI identifies the service the user is using. The response from OTT server are checked in the response event listener called content script. The response either in scrambled in binary format, which is video data, or in JSON format, which is video information. We only pass the HTTP response as JSON in an event listener called content script. This JSON also contains the name of contents and even where to look at video called playing position. We serve the OTT service by passing the content names in JSON. The browser extensions we have introduced still require more data manipulation. As a result, we show IPTV experiments that were not originally available. I have tested this system for 2 months. A total 9 million IGMP packets have been collected. This is the main use channel 21, 29, 32, and 106. And this user was watching TV after 21 o'clock on weekdays and 9 o'clock on weekend. We map what channel this user saw and look at the content name. All channels that were observed in experiment were movie channels, OCN, CGV, expressions, and screen. And this user saw 1 series, Criminal Minds, and 3 movies, as shown as table below. As you know, this user is me. So, we return the video watching history data to the user that was able to earn it to the service providers. So far, we have only looked at OTT in web browser, but we will look at OTT of smartphone in the future. Dynamic recommendation is our first consideration. Based on movies you saw, it introduced related products at online shopping mall. Or when you see the movie, the instant message will reply automatically. Would not it be convenient? Yeah. Thank you. It was Wenhyun so far. Do you have any questions?
Yes.
Yeah.
What is OTT again?
OTT is
Over the top.
over the top.
Over the top what? It's like.
Not news set-top box.
Oh,
Sorry.
set-top box.
Yes.
One,
Yes.
why are you interested only in the time and the title? Why not who were there? For example,
Who?
I mean, for example,
As family.
and also like in the content you're watching the video, there were some actors, some you like, and some actors you don't like, or
Oh, right.
I mean, why don't you think of, I mean, if you want to do this, you want to see people these days watch TV not alone. They watch the TV together in social ways.
Right.
I mean, why don't you do it? And if you know which the title of the content, and if you have the content information, you can trace out what was there when you interact with the content, and which one you were posing, and who were there, and many different things, right?
Right. So our next problem is identify one user who are watching the video in the group.
So one extension is people outside, people you are watching the TV together,
Yes.
and people who are connected with you with the SNS, right? So here is TV,
Yeah.
here is you, and people around you,
Yeah.
people connected to you, and the interaction to the TV,
Yes.
right? And the content in the TV,
Yeah.
they are all different objects, right? So, for example, in the recommendation system you wanted to develop,
Yeah.
what does it recommend, based on what information? Does it make recommendation of new movie or new book or something based on the content, based on the title of the movie you watch it, or based on the content? I mean, the objects in the movie.
Object in the movie.
Oh, you do it.
Yes. Or
you
in
do it.
object in the movie in a shopping mall or right.
Okay, so you identify the objects you watched in the movie.
Yes.
Oh, but you didn't say that, right?
Right.
Right. So it's not only the content, the title of the content, but also the objects in the content.
Right. This information identified from frame position
That's right.
of the movie
Right.
or TV series. We can image processing of video content. We can detect the object of video.
Okay.
So you collected the logins information for whole channels,
Yes.
right?
Right.
So then, is it really important, helpful for users?
Yes.
Or
It-
like,
It's actually I asked Cerebral's service provider, can you serve IP broadcast group table? So it's company secret, so I manually ignore. So it's limitation.
so I mean, for each channel, it can
Yes.
be the very important information for that channel service. But if we maintain 4 channels, the logging, so you know the previous like hitman, channel hitman,
Yeah.
from okay, from this information, what we can do. So channel service provider, they can do change the channel numbers or for example, okay, the Netflix only provides some commercial contents such as movies and TV dramas.
Yeah.
Then based on some categories, they can recommend some category
Yeah,
to users.
right.
So that can be the movie channels. However, if we have all our information,
see.
what we can do?
I miss it. I understand what you say.
Oh, so from my side, if we connect nowadays there are a lot of speakers, right? If we have some, we connect IPTV set up with the speaker, then speaker tells us there might be interesting news or interesting sports events or showing up in TVs and it recommend to me.
Yeah.
Yeah, that can be helpful for users, but
Yeah.
so anyway, for this information, what we can do? Channel heat map. And still for Netflix OTTs, we can choose different user IDs.
Yeah.
One user ID we can divide into we can register several different persons for one account.
Yes.
But in
Profile.
IPTV,
Isn't
it
it?
is very hard to
Yeah,
differentiate which family member shows the TV channels, right? So I think collecting the data is very important step because as a big data researcher, we do not have enough data. So anyway, we have collected the data in different views, then we can do lots of things, I think.
Yeah. Thank you.
So any other comment?
So exactly what is the motivation of this work? Means like, why you think that user side recommendation means like if the recommendation ends up on the user side, it's better than the existing recommendation system, which, for example, Netflix or other service provider actually is providing already, because they also have some recommender system. Why? How different this would be from theirs?
Directly.
Yeah.
It's in your hand.
Yeah.
It's in your
DIY.
hand.
Means like,
I want do it myself for my.
so
for
then
me.
why you need a recommender system? You can just think of an action movie, I can play an action movie.
So Netflix is limited on only the content provided by Netflix. So he combine all different
Yes.
TV systems.
I'm so more. For example, I saw in the IPTV a transformer, and in the Netflix I saw metric. So, but the recommendation result is based on metric in Netflix. But I want transformer metric is combined based on data. I
So
want
you want
this.
to combine all the recommendations.
Yes. So I want integrating the data.
That is actually the main
Yes.
motivation.
So if you collect this one, actually is in content-based the recommendation.
Content based.
It's,
Yeah.
it's kind of content-based recommendation. However, nowadays Netflix and other services they provide the collaboration recommendation.
Yeah. Right.
So then how we can do that with this one? So the content-based, so it works good, but nowadays the trend is moves on to
Yeah,
collaboration. It's the recommendation. So still, you might find some very good service by analyzing this data. So I'm not sure what can be.
Thank you.
So anyway, collecting of the data information is really first step to the more helpful things.
Thank you.
Agree. I can understand this is the first step, but
Yeah.
you can go a lot further than you think now.
Yeah. Thank you.
Okay. So, trying to recommend some